Hi guys, welcome back to another video. So in this video, we'll be solving this problem, largest sublist sum. It's a medium level problem. So let's see the problem statement. Given a list of integers, nums, return the sum of a non-empty contiguous sublist with the largest sum. Okay, so we have to find the maximum sum of a non-empty contiguous sublist, or we can call it as a subarray. Okay, so let's see the sample. Given this and output is 22 and we got the max from this sublist 3 minus 1 comma 20. Okay, so this is okay. So let's see how we can solve this. So we are given this sublist, we are given this list, and we have to find what is the which sublist gives us the max value. Okay, so the first approach is So first approach in which we can solve this is a simple brute force approach in which we will iterate through all the sublist and we will check if it's greater than max, which we are storing in a max variable, and if it's greater than max then we will store that value in a max. So this is just applying two loops and checking for every sublist. So the time complexity for this will be O of n square, but as n is of the order 10 to the power 5 or 6 something, so this solution will give us time limit exceeded. It will exceed the time limit. So the efficient way in which we can solve this is there is an algorithm which is called as cadence algorithm. It's a very famous algorithm and it is used to solve this problem, max subarray sum. So we'll apply this algorithm in this problem and we'll see how we can solve this using this algorithm. So okay, so let's take this. Okay, so in this algorithm, what we do, we take two variables, which is max till here, and we initialize it to 0, and then we take max so far, and we apply a loop from the starting index. So suppose we are applying a loop. Let's apply the loop plus, and what we do, let's suppose our ith pointer is in this index at the 10. So we will check mx. Let's take the short name to it. This is mxh and this is msf. So mxh will be max of 0 comma mxh plus, let's take our name of the array arr of I, and msf will be max of msf comma mxh. So this is the algo, this is the simple algo, and let's see how it's working and how we are getting the max, and we will return this value, return msf. So let's see how it's working. So suppose of I is on the starting index, so our mxh will become, so our mxh will become the max of 0 or mxh plus ar of I, which is 10. So mxh will become 10, this value, and msf will be max of msf. So initially msf was 0, so it will be now 10 because our mxh is 10. So now our I will move forward. Now we'll check and now we'll again check mxh is equals to max of 0 comma mxh plus ar of I. So our mxh will now become 5, 10 minus 5, so 5, and msf will remain same because 10 is greater than 5, so our I will move on. Now similarly it will go from max, mxh will be max of 0 comma 5 plus 12, this 12, this 12 and this 5, so it will be 17. And now our msf will change from 10 to 17 because 17 is greater than 10. And now I will move on. Okay, so our I will move on,
And now what we're doing, we will check if mxh plus ar of I. So 17 minus 100 is minus 83. So minus 83 is less than 0. So mxh will become now 0 and msf will remain 17. Because why we are making is like this 0, because this, because after, because this sublist is giving us a negative value, so we don't have to now consider this sublist. We don't have to consider this sublist. Now we will start from 0, because the negative value is no longer be giving us a max value. So we will start from 0 only, and we are storing msfh as the maximum. So we are at every point we are storing msf, which is a max so far, and mxh will is max still here. So mxh will be now 0 and msf will be 17, so our I will come here. Now we will check mxh plus ar of I, which is 3, so it's greater than 0, so we will again store this, and msf will remain 17. Now I will move on, and now it will, mxh will now become 2, msf will remain 17, which is the max so far we got from. And now I will move on again, and mxh will be 20 plus 22, 20 plus 2, which is 22, so it will become 22, and msf will now update to 22 because 22 is greater than 17. So after the loop will get terminated, so we will get this value 22, which is our answer. So this is the concept. We are just updating mxh. Like if mxh gets to the negative value, then we will update it to 0, or it will get updated if the value is not 0, if the value didn't get negative. So this is the cadence algorithm to find the maximum subarray sum. So let's code the solution out. So first we will use the brute force approach. So we'll store our answer here. Initially, if we are starting from the ith index, then we will store this, and answer will be max of answer comma temp for the single value, and it will be I plus 1 j is less than j plus plus. Temp will be plus equals to nums of j, and answer will be answer max of answer comma temp. Okay, okay, so we will return answer. So let's see. So we got accepted, but after submitting it will give TLE because it's O of n square and n is of the order. Okay, so we got the wrong answer on this. Okay, okay, so we left a case where all the values will be negative. Let's take that case also. So we are given this, suppose we are given this list where all the values are negative. Where when all the values are negative, so there's no advantage of adding the values, because it will only decrease the value by adding the negative value. So we just have to find the max value in this, because we have to take a non-empty contiguous sublist. So we have to take the only the max of this array. So the max in this array is -1. So that will be the answer, because if we add -1 to any number like -2, it will decrease the value. And we have to find the max. So there's no benefit of adding any value. So we just have to return the max of this value. Okay, so we have to check first if all the values are negative. So we will take bool flag equals to, let's suppose true, and here is the I is less than and I plus plus. If nums of I is less than 0, if we got the case where if any of the value is positive in our array, so we will get flag equals to false and break. And if any case didn't came where the value is positive or 0, so the flag will remain true. And if flag remains true, then we will return star max element of This is the STL in which we can, this is a short way in which we can return the max value. So we'll return max. So let's run this. So we got accepted. Let's submit. Now I think it won't give the wrong answer. It will give us time limit exceeded, right? So it gave us time limit exceeded. So let's code the cadence algorithm. So we will comment out. First we have to copy paste this. The first condition where when all the values are negative will remain same. And now we will take two variables, mxh equals to 0 and msf equals 0. Now we will try and mxh equals to max of 0 comma mxh plus nums of I, and msf will be max so far, max of msf comma mxh. We will return max so far, which is msf. So let's run this. Okay, we got accepted. Let's submit. And now it passed. Okay, we got the success. It took only 13 milliseconds, which is faster than 70.12%. Okay, so this is the approach. This is a cadence algorithm, and it is in this way we can solve this problem. So the time complexity of the cadence algorithm is simply O of n because we are applying only one loop. So thank you for watching, and I see you in the next video.